So this video is going to show you how electromagnetic induction works. So what electromagnetic induction is, it's a process by which an electrical current is produced by a changing magnetic field. And the way that you're going to show your teacher that you know what electromagnetic induction is, you're going to need a coil of wire. Now, if you saw some of the other videos, you're probably familiar with this wire. This is what we have in the classrooms. It is a metal wire that's covered in an insulator that is a blue color. So you can use this wire to show you know what electromagnetic induction is. And what you're going to do with this coil of wire is you're going to wrap it. I usually use my fingers to make the coil. Use a couple fingers just so that your magnet can fit through the coil, because that's how electromagnetic induction works. You don't want to make the coil way too small. So keep wrapping your coil. Okay, there's your coil of wire. And like I said, it's a process where an electric current is produced by a changing magnetic field. And what that means is you're going to produce a current of electricity just by passing a magnet back and forth through a wire. Now we know the word induction means that the two things are not touching, because we talked about conduction. Conduction is where two objects are touching. So your magnet should technically not be touching the coil of wire. So you do want to explain that to your teacher, that you know that electromagnetic induction, there's no touching between the wire and the magnet, but an electric current is actually being created by moving a magnet just back and forth. Now when you made the electromagnet, if you haven't seen that video just yet, the electromagnet was where you wrapped the coil of wire around the nail and you created a magnetic field using a current of electricity. We're doing the opposite. Now we're taking a magnetic field and creating electricity. So I like to think that electromagnetic induction and an electromagnet are kind of opposites of each other, and it really shows you the relationship between magnetism and electricity. And that's what our whole unit is about. It's about electricity and magnetism. And now at the very end here, we're learning that there's a very close relationship between magnetism and electricity. I can take magnetism just by showing you electromagnetic induction here, that a magnetic field can create a current, meaning electrons are starting to flow through this wire just by moving the magnet back and forth. And the way that I want to show you that a current is actually being created, rather than you just taking my word for it, we can hook this up. We can hook these wires up to this little device here. You can see that there's an A in the center. And at this point you should have learned that A stands for amps, and amps is the unit of measure when you find the current. So current, the unit for current is amps. So I can show you by hooking this wire up to the ammeter that an electric current is being produced by passing the magnet through this coil, this electromagnetic induction setup. Now it doesn't work that great if you were to do it with this wire that I have here, so I'm going to show you something a little bit fancier. So what I have is copper wire. This is a really good conductor, copper being a metal, and a good conductor. So I'm going to use this coil of wire, the copper coil. And I'm actually going to set up a few things here, so give me a second. I'm going to steal some of these cables we have in the bucket. Alright, so I just wanted to get two wires here, and I'm going to hook my copper coil, because I got a staple in here. I'm going to hook one end of the copper coil with one clamp, and I'm going to put that in the ammeter. And then I'm going to take the other end of the coil, and I'm going to put a clamp on there, and just attach it to the ammeter. It's just a little bit more of a secure way to do it. And I'm hoping that you can see the ammeter and that I'm not bumping into it. Hopefully you can see the dial. It's pretty close to reading 0 right now. I'm going to take this magnet and I want you to pass it through here. I don't know if you can see, but this is electromagnetic induction. Let me move this so you can, I think we'll get a better reading if I move it over here. It was working a little bit earlier for me. Alright, I think I had it on this one. It worked better. So give that a try. Oh, you know what? Ah! That fell off. That's why it's not working. Okay. Now this will work. Alright, there we go. I don't know if you can see that. Let's see if I can move it a little bit closer. Whoop. Alright, and you can still see the coil. Can you see the dial moving just a little bit on the ammeter? Now give this a try. See if your teacher has the copper wire, and you can do this same exact setup where you move the magnet back and forth through this coil wire, and you get a very low current, maybe a reading of 2 or 3 amps there. The faster you do it, the higher the current, the faster that those electrons are going to flow through that copper wire. So give it a try using a magnet to create an electric current. And this whole setup, again, remember, is electromagnetic induction. You're taking a magnetic field and you're creating an electric current through this wire.